Alright guys, the purpose of this video is so that the students who are doing AP testing still have an actual lecture to go by. Feel free to use this video as well if you need to re-watch the lecture for the homework assignments. So this is concept 64, basic trig identities. A trig identity is an equation involving trig functions that is true for all values for which every expression in the equation is defined. The identities help evaluate functions, simplify expressions, verify identities, and solve equations. So the first ones, we've been familiar with these, actually all of these basic identities already in the past, whether it be last year or when we did the unit circle. Tangent theta is sine theta over cosine theta. Cotangent theta is cosine over sine. Then what you have here, the reciprocal identities, you have sine, cosine, tangent, cosecant, secant, cotangent, and then they're all equal to their reciprocal identity. Okay, so again, this is all stuff we've already done, worked with in the past. So the main idea behind identities is you're kind of just substituting in and then finding whatever it is that they're asking you to find. So for example, this first one says use the quotient and reciprocal identities to find each function value. So if secant theta is equal to negative square root 30 over 3, find cosine theta. Cosine theta is right here. Cosine theta is equal to 1 over secant. Okay, so if I need to find cosine theta, I'll say cosine theta is equal to 1 over secant theta. Okay, I already know what secant theta is. Secant theta is right here. Okay, it's given to me. So I could say that's equal then to 1 over negative square root 30 over 3. Okay, now this right here is a complex fraction, something divided by a fraction. Recall from way back when you first learned how to divide by a fraction, okay, you switch from division to multiplication, and then you multiply by the reciprocal. 3 over the fraction is negative square root 30, doesn't matter whether it's the top or the bottom. Okay, which is of course anything times 1 is just itself. Okay, now from here I have to get rid of the square root in the denominator. So remember our pattern, you would multiply top and bottom by square root of 30. This would give you negative 3 square root 30 over square root 30 times square root 30. You're going to get just 30. 3 over 30, that does simplify. 3 over 30, 3 is a common divisor here, so you'll get negative 1, or just square root 30 over 10, because 3 divided by 30 is 10. Okay, next one. If tangent x is square root 2 over 4 and cosine x is negative 2 square root 2 over 3, find sine of x. Okay, so I look at my tables here of identities. Okay, I have tangent theta here, 1 over cotangent, and I also have tangent theta here, sine over cosine. The hardest part of these identity problems is just identifying which one it is you want to work with. You might not get it right the first time, but that's okay. Okay, you just need to try it out and see if it gets you to the solution. I'm working with tangent, cosine, I need to find sine. I'm not going to use this one because cotangent won't get me anywhere. But if I use this one, this quotient identity, tangent is sine over cosine, then might be able to get somewhere. So tangent theta, doesn't matter, let's change it then. Tangent x, okay, is sine x over cosine x. Well, look at that, I have 2 of these already. Tangent x is right here. Cosine x is right here. So just substitute it in and then solve for sine of x. So then I'll have square root 2 over 4 is equal to sine x over negative 2 square root 2 over 3. Okay, don't forget your algebra here, how to solve for an unknown, treat it like a variable. I'm going to multiply both sides by negative 2 square root 2 over 3, so I can cancel out the denominator. negative 2 square root 2 over 3. Okay, and what happens here then is these guys cancel, and what that'll give me here on the left side, I'm gonna have, I still have sine x, oops, sine x on the right side, negative 2 square root 2 times square root 2, that'll give me negative 2, that's him. Okay, square root 2 times square root 2 is square root of 4, which is 2, so times 2. Okay, 3 times 4, 12. This will be negative 4 over 12 is equal to sine x. Okay, and then lastly, this simplifies. It'll be negative 3, not negative 3, negative 1/3. That is equal to sine x, or sine x is negative 1/3. Okay, next one. Cosecant beta is equal to 7 over 3, and cotangent beta is equal to negative 2 square root of 10 over 3. Find secant beta. Okay, I have cosecant and I have cotangent, so let's go over to our table of identities here, okay, and see what we can work with. Cotangent's right here, cosecant theta over sine theta. I also had cosecant. Cosecant is where's cosecant? Oh, right. Yeah, no. 1 over sine theta. Sorry. Cotangent is cosine over sine. Cotangent is also right here, 1 over tangent. Okay. I'm going to go off the bat and say maybe the one that's most useful here would be either this one or this one. Remember, that's the hardest part of these problems, so just try to work it out and see if you can go somewhere. If you don't, okay, then backtrack. That's fine. I'm going to start with this one right here. Cotangent is cosine over sine. Why? Because I do have, oops, here we go. I do have cotangent. Now, I don't have sine and cosine, but I do have cosecant. Okay, this guy is the reciprocal of sine, so I can say then sine beta, if cosecant beta is 7 over 3, then sine beta would be 3 over 7. Okay, secant, the one they want me to find, this is the reciprocal of cosine, so I'll know that secant, or I could say this, cosine beta will be 1 over secant, the reciprocal, secant beta. Okay, so cotangent beta was cosine beta over sine beta. Okay, and again, I got this from up here, cosine over sine. Okay, let's plug in what we have. I already have cotangent beta right here, negative 2 square root of 10 over 3. So, oops, let's do this better with an arrow like this. So then I'll have, replace this guy with negative 2 square root 10 over 3 is equal to cosine over sine. Because I have cosecant, I was able to get sine. So then cosine beta on top, all over sine beta, which is 3 over 7. Okay. So multiply both sides by 3 over 7. They cancel out there. These guys, I'm going to have negative 6 square root 10 over 21. That's equal to cosine beta. These guys do simplify. Negative 6 over 21. 3 goes into both of them, so this will be negative 3 over 7. Square root 10 is still there. That's equal to cosine beta. Now, I want secant. I have cosine beta, so then that means then I will have to plug this in to find secant. So you don't even have to plug it in. You know it's the reciprocal. So take the reciprocal of this, and that gives you secant. Secant beta then is equal to negative 7 over 3 square root 10. Again, I took the reciprocal. And then now I just have to get rid of this square root 10 in the denominator. Multiply top and bottom by square root of 10. That'll give you negative 7 square root 10 over square root 10 times square root 10. You'll get just 10, but you still have the 3. So multiply those and you'll get 30. 7 is prime, so it doesn't now simplify. So then you're done. Here you go. That's your answer. Okay, turn the page. Next set of identities here, we have the Pythagorean identities. There's 3 of them. One thing that I want you guys to make note of, that from these 3, we're able to come up with a number of other identities. Let's make note of them here, off to the side. So here's what I start with. I can subtract one or the other of cosine squared theta or sine squared theta to get the following identities. If I subtract sine squared theta from both sides, that'll give me 1 minus sine squared theta. So here's another identity. I can also subtract cosine squared theta, and that'll give me sine squared theta is equal to 1 minus cosine squared theta. Similarly, I can do the same with this identity. I can say, let's see, what can I get from here? Make another point there. I could say 1. If I subtract tangent squared theta from both sides, that'll give me secant squared theta minus tangent squared theta. So that's an identity there. Another one I can get is, let's see, tangent squared theta. If I subtract 1 from both sides, that'll be secant squared theta minus 1. And I could do the same thing from this one. If I subtract cotangent squared theta from both sides, that'll give me 1 is equal to cosecant squared theta minus cotangent squared theta. And lastly, I can also say then cotangent squared theta is equal to cosecant squared theta minus 1. If I subtract 1 from both sides, I get this one here. Okay, so looking at these now, excuse me, I'll have cosine theta and find cosine theta and tangent theta if sine theta is equal to negative 1/3 and cotangent theta is less than 0. Circle that. If cotangent theta is less than 0, this means that this value is negative. And if it's negative, I know cotangent is cosine over sine. Recall from our unit circle, cosine is x, sine is y. So then, if cotangent is less than 0, that means this value here is going to be negative. But to get a negative, that means you either have a positive divided by a negative or a negative divided by a positive. They give me here sine. Okay, sine theta is negative 1/3. Sine is y. So if y is negative, that means x is positive. So positive divided by a negative is negative. Okay, so that's this guy here. And what quadrant then would you be if you have a positive x and a negative y? You're going to be in quadrant 4. Sorry for the sloppy writing here because I can't because of the camera. You're in quadrant 4. Okay. Alright, so to find cos theta, I'm going to use this first Pythagorean identity because I have this given. That'll sine theta given, so that'll mean cosine squared theta plus, instead of writing this guy out, I'm going to sub it in with negative 1/3. Negative 1/3 squared, okay, is equal to 1. So I'm going to solve for cosine squared theta. Cosine squared theta plus negative 1/3 squared, that gives me 1/9. That's equal to 1. I'll subtract 1/9 from both sides. So then cosine squared theta is equal to 1 minus 1/9. If you have one whole, and one whole represents 9 pieces, and you, I don't know, eat one piece, you're left with 8 out of 9 pieces. Okay, this is cosine squared theta, so I gotta take the square root, so then that'll give me cosine theta. Cosine theta is equal to the square root of 8 over the square root of 9. Square root of 9 is 3. Square root of 8, let me see, I think in class I did it off here to the side, but square root 8, that would be 4 and 2. 4 is 2 and 2. Here's a pair of 2s, so that's equal to 2. 1 2 is left alone, so he stays home. 2 square root 2. 2/3, that doesn't simplify. Okay, found my first answer. Now I'm going to need tangent theta. So you look up here, right? It says I have to use a Pythagorean identity, so I have to use these guys here. So to find tangent theta, I'm going to plug into this formula here. They're asking for secant theta, but I know what secant theta is because I have cosine. Secant theta is the reciprocal of cosine. So if I have cosine, I could just take the reciprocal of that, and then that gives me tangent. That'll give me this right here. So tangent squared theta is equal to secant squared theta. Okay, secant squared theta is the reciprocal. It'll be 1 over cosine squared theta. I can take the reciprocal of this and plug it in, or I can take the reciprocal of this and just plug that straight in. Okay, doesn't matter, you'll get the same thing. For the sake of consistency, because I squared this value, I'm going to take this one and plug it in here for I'm going to plug it in here. Oh, I see the confusion. Okay, tangent squared theta plus 1. I'm using this identity here. Okay, that's equal to secant squared theta, again reciprocal of cosine. So that'll be 3 over 2 square root 2 squared. Okay. Okay. So then square. Yeah, I have a square root in the bottom, but I'm not too worried about it because I'm trying to figure out a value, not this one per se yet. Okay. So then square it. What that does is that'll be tangent squared theta plus 1 is equal to 3 squared 9. 2 squared is 4. Square root, square of square root, that cancels. So 2 squared was 4. So if this canceled with this, that just gives me a 2. So then 2 squared 4 times 2, that's 8. And you guys can see why I said earlier, doesn't matter which one you plug in. Okay, you'll get the same thing. Being the reciprocal here, of course, because it was secant. Okay, subtract 1 from both sides. That'll give me tangent squared theta is equal to, you have 9/8. Okay, I don't know, a pizza has 8 slices, but you have 9 slices. That means you have a whole pizza plus 1 piece over it, and then you subtract 1, meaning you eat one whole pizza. That's going to leave you with 1 slice, the extra one you had. So 1 out of 8. Okay, and I just realized I misspelled tangent there, sorry. Okay, take the square root. Okay, tangent squared theta, not tangent squared anymore, tangent theta is equal to square root of 1, that's 1, square root of 8, you already did that, it's right here, 2 square root 2. So then last step, get rid of the square root in the denominator. That'll give you square root 2 over square root 2 times square root 2, square root of 4, which is 2. 2 times 2, 4. Okay. Next one. Find cotangent x and sine of x if secant x is 6/5 and sine of x is greater than 0. So if this value is greater than 0, that means it's positive. Okay. Now, sine of x is y. So if y is positive, and then also here's secant of x. Secant of x is the reciprocal of cosine, so then that means cosine is 5/6, the reciprocal. Okay, let's backtrack to this problem. One thing that I forgot, and also in class as well, is cotangent was negative. You're in quadrant 4. Cosine was shown to be positive. If you guys recall, y was negative, so then tangent, which is y/x, this one would have to be negative. That's why we make note of this. Okay. Anyway, sine is positive, cosine is positive, tangent then y/x, sine over cosine, will be positive. Why are they all positive? This will be in quadrant 1. That's where both the x's and the y's are positive. Okay, so find tangent of x and sine of x. I'm going to use, and I have to use the Pythagorean identities. So to find sine of x, I'm going to use this first one. Okay, this is the common identity that I just used a lot. This one will give me cosine squared theta plus sine squared theta is equal to 1. I know cosine theta, so I'm going to plug it in. 5/6 squared plus sine squared theta is equal to 1. This will give me 25/36 plus sine squared theta is equal to 1. I'm going to subtract 25/36. You have one whole, you subtract 25/36. Shoot, I don't know, pretend the whole pizza is 36 slices. You eat 25 of those slices. How much are remaining from the whole? 11. So sine squared theta will be 11 out of 36. Take the square root. Sine theta then is equal to square root 11. It's just square root 11. It doesn't simplify. Square root of 36, you're going to get 6. Cool. So that's sine theta with this one. So then I still have to find tangent of x. So then I'm going to use this one right here because I need to find tangent, and they gave me secant. It's this one right here. So then I'm just going to do that math. So tangent square theta plus 1 is equal to secant 6/5 squared. So then tangent squared theta plus 1 is 36/25. Then I'm going to subtract 1 from both sides. So then tangent squared theta is equal to 36/25 minus 1. So okay, now it's a pizza of 25 slices, but you have 36, which means you have then more than a whole pizza. You have 11 slices more, but you subtract a whole is 25 slices. That leaves you with 11, the one you had over. Take the square root. Tangent theta is equal to square root of 11 over square root of 25 is 5. There's your other value. Okay, finally, last section here, we have another set of identities, the co-function identities and the even-odd identities. These are the ones that look a little more crazy, but they're actually not as intense as the ones we just did. These are just more so identifying what's equal to what, and you'll see how this works. Okay, sine negative theta is negative 0.97. Find cosine of pi/2 minus theta. Okay, so sine negative theta is right here. Sine negative theta is negative sine theta. So let's do that. Okay, sine negative theta, that's the one they gave me. I know that's equal to that. I know this right here is equal to negative sine theta. So then negative sine theta is also equal to negative 0.97. Look at that. Okay, now forget about this guy because again this is all equal, so just ignore him, he's gone. Okay, I'm going to divide both sides by negative 1. Okay, that'll give me positive sine theta. Negative 0.97 divided by a negative, negative over negative, that's positive. So then I'll have sine theta is equal to 0.97. Okay, I need to find cosine pi over 2. If you go up here to the top, cosine pi over 2 is right here. This is equal to sine theta. We already have sine theta, it's right here. Okay, there you go. Sine theta is equal to cosine pi over 2 minus theta, and then that's equal to 0.97. Done. Okay. Next one. Tangent negative alpha. If tangent negative alpha is negative 2.36, find cotangent alpha minus pi over 2. Okay. Tangent negative alpha is this. Go to this even odd and identities. Here's tangent negative theta. Okay, that's the one we have here, the negative angle. Okay, that's equal to negative tangent theta. Okay, so then tangent negative alpha is negative tangent alpha, which is negative 2.36. Okay, then I'm going to divide both sides by a negative. Did it freeze? I think it did. There you go. It's going. Okay. Divide both sides by a negative. Oops, forgot to use my red pen. That'll give me then that tangent alpha is positive 2.36. Okay, let's go here. Cotangent alpha minus pi over 2. Here's cotangent pi over 2 minus theta. That's tangent theta, which is the one we have, tangent alpha. Okay, so again, the symbol here is interchangeable. It doesn't really mean anything. It's just a symbol for the angle. So, okay, I'm getting close now. Tangent alpha, that's equal to then cotangent pi over 2 minus alpha is equal to 2.36. But, okay, you're not done. It looks like you got it, but this is alpha minus pi over 2. This is pi over 2 minus alpha. The orders here are switched. Okay, so then I need to fix this. To fix this, I'm going to factor out a negative from the angle here. By factoring out a negative, that's going to switch the signs of the two values inside, so I can then switch their order. Okay, that's equal to 2.36. Okay, I have cotangent of a negative angle. Here's cotangent of a negative angle. Okay, cotangent of a negative angle then is negative cotangent of that angle. Okay, so I have, again, cotangent negative angle, cotangent negative angle, that's negative cotangent theta. So I can then say then that cotangent, this guy right here, is equal to then, why is it freezing again? There you go. That would be negative cotangent of alpha minus pi over 2. That's equal to 2.36. Lastly, divide both sides then by negative 1. And that'll give you then cotangent alpha minus pi over 2 is equal to negative 2.36. Okay. Last one. If secant beta minus pi over 2 is equal to negative 3.62, find cosecant of negative beta. Secant, here it is. Secant pi over 2 minus theta is equal to cosecant theta. They want us to find cosecant negative beta. Okay, so then the thing is, you'll notice that here's beta minus pi over 2. Pi over 2 minus theta. Okay, so similar to the previous problem here, I'm going to have to factor out a negative from the angle. That'll allow me to switch the symbols. Pi over 2 minus beta. That'll be negative 3.62. Okay. Okay, I have secant of a negative angle. Secant of a negative angle is equal to secant, meaning it doesn't change. So then I could just say then, okay, well, secant of negative angle is just secant of that angle. Then secant of pi over 2 minus beta is equal to then to negative 3.62. Okay, I need cosecant negative beta. I have secant of this. Here's secant. Secant is equal to cosecant theta. Okay, that's what I have. Pi over 2 minus theta. I have pi over 2 minus beta. That's equal to that. So then I could just say, okay, this then is cosecant. So then cosecant beta is equal to negative 3.62. Cool. I need cosecant of negative beta. Going back here then, here's cosecant. I have cosecant beta is this. Negative cosecant theta is cosecant of negative angle theta. So then what I'll do then is divide both sides by a negative. What that allows me to do is transfer the negative to the left side. This gives me negative cosecant beta then. That's equal to positive 3.62. There. That's what I have here. Whoops, that's what I have here. Negative cosecant theta, negative cosecant beta is this. So then this is cosecant of the negative angle. So then cosecant negative beta is equal to 3.62. Okay, that wraps this one up.